Good morning, students. Our today's topic is sequential circuits and flip-flops. Sequential circuits are the circuits whose output at any instant depends upon the inputs at that instant and at the present state of the circuit. With the present state, we means that the contents stored in the memory element, those are basically the outputs of the previous stage of the circuit. So, a sequential circuit's output depends upon the present input and the past outputs. So a sequential circuit is a combinational circuit with memory or storage element in feedback. And the sequential circuit's output depends on inputs as well as the previous state of the circuit. Types of sequential circuits. We are having two types of sequential circuits, synchronous sequential circuit and asynchronous sequential circuit. In the synchronous sequential circuit, behavior of the system depends on the input only at discrete instant of time. That means we will be getting the output of these type of synchronous circuits when we will be providing the inputs at the clock pulses with the discrete instants of time. The storage elements used here are the clocked flip-flops. In the asynchronous sequential circuits, behavior of the system depends on the inputs at any instant. That means output can be taken with the inputs at any time and there will be no clock pulses. Storage element used here are the time delay elements and latches. Latch is a basic storage device here and it can store a single bit in it. That single bit may be 1 or maybe 0, and when something is stored in the latch, the state of the latch is known as set, and when nothing is stored in the latch, the state of the latch is known as reset. Here we are having two inputs, S and R of the latch. S is as the set and R is for the reset. We are having two outputs, Q and Q bar. Those are always complementary to each other. We are having four options for the inputs. Like we may give the S is equal to 0, R is equal to 0. The second option for the input may be S is equal to 1, R is equal to 0. We can have S is equal to 0 and R is equal to 1 also, and S is equal to 1 and R is equal to 1. So now we will be checking that how the latch will respond when we are giving the four input options one by one. So when we are giving S is equal to 0, R is equal to 0, then the output of the latch will not affect. That means if the output of the latch was 0 in the previous state, it will remain 0, and if it was 1 in the previous state, it will remain 1. In the other words, we can say if we are providing the input 0 0, then if the latch was set in the previous state, it will remain set, and if it was reset in the previous state, it will remain reset. And when we are going to provide the inputs S is equal to 1, R is equal to 0, the output of the latch will be 1 and the Q bar, the complementary output, will be 0. So in this stage the latch is going to be set. If we are providing S is equal to 0 and R is equal to 1, then the output will be 0 and the complementary output will be 1. That means the latch is going to be in reset state. And if we are providing S is equal to 1, R is equal to 1, then there will be no option for output and the complementary output to being the complementary to each other. So this is a prohibited stage and we will not provide 1 1 both the inputs same anytime. SR flip-flop. Basically latch and the flip-flop are basically the same things. These are both are the memory devices. We can store a single bit in latch as well as in the flip-flop. The major difference is that we have providing the clock pulse to the inputs of the flip-flop. Here we can see in the circuit diagram we are having S and R, two inputs with a common clock pulse, and we are having the two outputs Q and Q bar. These two outputs are complementary to each other. So the truth table says that if S is equal to 0, R is equal to 0, then no matter we are providing the clock pulse or not providing the clock pulse, this will not affect the inputs, will not affect the output. That means the input is 0 0. In that case the output will remain same, and if the output was set in the previous state, the latch will be, or the flip-flop will be remain set in this state, and if it was reset, it will remain reset in this state. And when we are going to provide S is equal to 0 and R is equal to 1 with the positive clock pulse, then the output will be 0. That means the latch will be reset. If S is equal to 1, R is equal to 0 with the positive clock pulse, then the output will be 1. That means the latch is going to be set in this state. If S is equal to 1, R is equal to 1, even with the positive clock pulse, this stage will be a forbidden state, and we will not provide the S and R both equal to 1 to the inputs. D flip-flop. Basically this D flip-flop is a slight modification of SR flip-flop. As we can see in the previous slide, the truth table of the SR flip-flop says that when we are going to provide both the S and R flip-flops 0 0, there will be no change in the output, and when we are going to provide S is equal to 1 and R is equal to 1, again the same inputs, this is basically a prohibited stage, that we were not going to provide these 1 1 inputs. So we are left with the only two options of the input, that is 0 1 and 1 0. So if we can see here that both the S and R in the both options are complementary to each other. If we are providing this option that S is equal to 0 and R is equal to 1, or in the second case S is equal to 1, R is equal to 0, both the inputs are complementary to each other, and we are going to use this property in the next D flip-flop, that we will provide a single input D here. We will be connecting this D to the S directly, and we will be connecting this D input to the R through a NOT gate. That means if we will be given the D is equal to 0, the S is equal to 0 and R will be equal to 1, and if we will be providing D is equal to 1, then S will be 1 and R will be equal to 0. So looking at the truth table of this D flip-flop, when D is equal to 0, then the S will be 0 and R will be 1. That means the output of the this D flip-flop Q will be equal to 0. That means it will be in the reset state. And when we are going to provide the D is equal to 1, then S will be 1 and R will be 0. That means the Q will be equal to 1 and the flip-flop will be in the set state. And the next is the JK flip-flop, and the problem in the SR flip-flop that we cannot provide the both of the input S and R as 1 1. So this is known as a raise around condition, and this problem can be solved in the JK flip-flop. So as we can see in the diagram here, we have provided the feedback to the like inputs of the circuit. Here there is a feedback from the Q to the K input. With the K input we are here providing the feedback, and from the Q bar we are here taking the feedback and giving it to the input of the flip-flop with the J. So when we will be taking the inputs J is equal to 0, K is equal to 0 with the high clock pulse, there will be no change in the output. That means it will be remain same at it was in the previous state. If the circuit was set in the previous state, it will remain set. If the circuit will reset in the previous state, it will remain reset. And when we are going to provide J is equal to 1, K is equal to 0 with the high clock pulse, the output of the circuit will be 1. That means it will be set state of the circuit. And when we are going to provide J is equal to 0, K is equal to 1 with the high clock pulse, the output of the flip-flop will be 0. That means the output, the flip-flop will be in the reset state. And when we are going to provide the j is equal to 1, k is equal to 1, then the output will be in the toggle stage. Here the toggle means if the output of the previous stage will be was the set, then the output of this state will be reset. And if in the previous state the circuit was reset, now with the 1 1 input it will be set. That means we can provide the 1 1 input here and we can toggle the output of the previous state. T flip-flop. Here the name T is for the toggle, and this T flip-flop is a modification of the JK flip-flop. As we can see in the previous slide, and the truth table of the JK flip-flop says when we are going to provide both the input 0 0, there will be no change in the output, and when we are going to provide both the inputs same 1 1, then there will be a toggle. So we can utilize this property in the next T flip-flop. Here we will be having a single input T, and it will be directly providing to both of the inputs J and K. Here you can see we are not using any NOT gate. That means if T is equal to 0, J will be 0, K will be 0. If T is equal to 1, J will be 1, K will be 1. So here if T is equal to 0, J is 0, K is 0, that means it will not affect the output of the circuit, and it will be remain same. That means if the circuit was set in the previous state, it will remain set, and if the circuit was reset in the previous state, it will remain reset. And when we are going to provide the T is equal to 1, that means J will 1, K will 1, and according to the JK flip-flops truth table, the state will be toggled. Toggle means if in the previous stage the circuit was set, it will be reset in this state, and if in the previous state it was reset, then it will be set in this particular point with the inputs J is equal to 0 and K is equal to 0. Thank you.